Okay, let's look at the homework for the fourth lesson. Let's start the lesson by looking at the correct answers. This is the code that we gave out. We included two mistakes inside it, two Easter eggs that you're supposed to try and fix. This is the first Easter egg that you're supposed to try and fix. Okay, let's start with talking about the definable function. Char is a imported letter, while n is the offset. We try to find the remainder of n divided by 26, because since offsetting 26 and offsetting 0 would give you the same character. Keep in mind that this has to be within an alphabet set. Then we see if it's within the capital alphabet set. If it is, then we do the following 3 lines of code. If not, then we see if the character is inside the lowercase set. We do the next 4 lines of code. If the character is not inside the uppercase set or the lowercase set, then we just assign it to new char. We don't change it. Okay, let's look at if the character is inside the capital set. We first add n into the char and see if it's bigger than a capital Z. If it is, then we subtract 26 to keep it from overflowing. If not, then we just add n, don't subtract 26. So we can make sure that the offsetting is always within the capital alphabet set. Similarly, if the character is inside the lowercase alphabet set, then we need to keep the character inside the lowercase and keep it from overflowing. This is where the first Easter egg is. Or char plus n equals lowercase z is wrong, because if or char plus n equals lowercase z, then it is still inside the lowercase alphabet set. If it is greater than lowercase z, then that means it is overflowing. If it isn't bigger than z, then we don't need to subtract 26. We can just add n. We already mentioned that if char isn't in any of the alphabet sets, then we just return it as new char, and then return new char. And then the new string here has to be a blank string. And then the chstr is our blank text. Our offset is 51, and then we make a for loop. The for loop just takes the first character out of the ch string and assign it to ch. And then we do a call function and use the char convert function that we already made up. And then the return character is an encrypted character. Then we add the return value with new string to create a new string. Then why would we disable this line? Do you know why? It's because chr convert does not exist as a function. We defined it as char convert, char. we lost the A while we were typing. It's the second Easter egg. Next, let's look at the student's work to see if it's right. Firstly, we have A. The second line is wrong because you're supposed to try and find the remainder of n divided by 26 instead of just to n, because that way it would be really hard to control the overflow. This student didn't get the first Easter egg right. It should be greater than. There are no other problems in the code. We just had to change the offset in order to verify whether the code was right or not. You found the second Easter egg. Good job. I disabled the rest of the code because you don't need to redefine the function. If you define it once, you can use it more than once like for the whole. If it's because you wanted to change the offset, you can just change it here. Next, let's look at another student called Code 2. Code 2 gave us an image, so we can't really edit it. We can only tell you what's wrong. We can't actually like help you remake it. Firstly, the first part is right, and we got the remainder. But the next part is wrong. We cannot do or on the if statement. It has to be a and. We are trying to see if the character is within the set of capital A to capital Z. So this if statement has the wrong logic. And then on the else statement, you forgot to like put a space or enter to make a new line. There are lots of mistakes after that. We're not gonna like say each one. Next time, try to send .py files instead of .png. That way we can help you edit it. Next, we have code 3. Code 3 is illogical because you assigned different values to offset 3 times in a row. The only one being used is the third one. If you want to make the first two work as well, you should put something in between to make it work. Next, let's look at Adrian's work. They didn't find the first Easter egg. It should be bigger than instead of equals. But they did find the second one because they spelled it right. The end, I disabled all of the ending codes because we don't really need it. Let's run the code and see how it works. Yes, it's right. The first one is the original plain text, the second one and third one is the encrypted text. Okay, let's look at the next person called Brooks. Brooks did really well this time. You found both of the Easter eggs, and there isn't much problems. Good job. In order to verify the code, I changed the offset into 51. Let's run the code to see how it does. It's right. It starts with VD and has SVN instead of 2 now. Let's look at the next person called Brian. Okay, so the problem is that the character should be a capital Z instead of lowercase z at the start. Another point is you missed the first Easter egg. It's supposed to be a larger than sign instead of equals, and you also did the equals sign wrong. If you want to do equals, you have to put 2 equals sign. At the start, you have to have a blank text string instead of one with a space in the middle. We turned the offset into 51 so we can verify if the code is right or wrong. You also spelt for the second Easter egg, you got it right, but you also planted one for us. You spelt ch into chr. Let's run it to see how it does. Okay, next let's look at Daniel's. Oh, this is the homework for the third one. All you did was just to add the offset onto it. You didn't try to find sets. You put the cipher script into the new string and printed it. You also made a decrypt script, which was pretty good. Using the same way, just subtracting offset onto it, off of it. There's no mistakes in it. Good job. Let's run it. Okay. As you can tell, the encryption makes it look really weird with a bunch of spaces in the middle, but those aren't actually spaces. Those are called control symbols. They they don't actually have a symbol for it, so they just use a space. A cool thing to know is that the decryption still turns it into the cake is a lie. This is a .txt file, so you can't run it. Let's look at Dylan's next. Okay, you didn't get the first Easter egg because it's supposed to be larger than instead of equals. It was right, but we wanted to confirm it, so we changed the plain text and offset into the original ones that we got so we could verify. Let's run it to see it's right. Let's look at Ellie's. Oh wait, it's a .ra file. The released files is here. Oh, don't do this next time. Actually get the code in. Next, let's look at Gary Zhang. Good job, there's no problems with the code whatsoever. Even though it's right, we still need to verify it. We changed the plain text and offset into the normal ones, and let's run it. Yay, it's right. Okay, that's good. Let's look at Grace's next. Okay, over here, it's kind of illogical because we saw that ord char plus n is bigger than capital Z, so after we add n to it, we still need to subtract 26. In your original code, you didn't subtract 26. Good job, you found the Easter egg over here. We changed the plain text and offset in order to verify it. Let's run it. Okay, so it's right. SVN and all that. Okay, let's look at Henry's. This part is wrong because you spelled char wrong. It should be CHAR instead of CHR. The logic over here is also kind of weird because since we found that ord char is lesser than lowercase z, so we don't need to subtract 26. If we subtract 26, it would be out of the lowercase set. Good job, you found the Easter egg over here. We changed the offset here to verify if it's right or not. Let's run it. Okay, so it's right. Next, let's look at Jessie Lou's. You didn't find the Easter egg here. It should be larger than instead of equals. You did, however, find the Easter egg over here. You spelled it right. We changed the offset and plain text to verify if the code is right or not. Let's run it. Okay, so it appears to be right. Okay, let's look at Matthew's. Over here, you got it wrong because it should be a capital Z instead of lowercase z. You, however, found the Easter egg. Good job. Again, we change the plaintext and offset to verify if the code is right or wrong. Under it, you also change the offset to 261 and redid the whole thing, and you also turned it to 27. Okay, let's run it. The second one is from the offset as 51, and the last two are from the offset as 261 and 27. Okay, the next one is Michael's. You didn't find the Easter egg over here? It should be a greater than sign instead of an equals sign. Over here, the two prints should be outside of the for loop, so there shouldn't be indentation over there. Because if it's indented, then every single time you get a new digit inside of the new string, it would print out. So that's not what we want. All of them would be unfinished. So that's not what we want. You need to get out of the for loop and then do it. Next, let's look at Richard's. Richard, you didn't find the Easter egg here. It should be a larger than sign instead of an equals sign. We changed the offset to 51 to verify it. If you want to make a new one, all you have to do is change the offset. You don't have to copy everything again. Okay, let's run it and see how it goes. Okay, yep, the results are right. I don't know why, but Richard made 2 copies and sent it to us. I don't know why. Next time you only need to send 1. This concludes today's marking for the students. I hope you have a nice day.